Hi, this is Prasanna from Wave Academia. Welcome to this electronic edition. In this video, we are going to discuss how to design inverting amplifier with the help of Matlab Simscape. So before we moving on to the Matlab, now I will tell you how the non-inverting amplifier is working. This is the circuit diagram of non-inverting amplifier. This amplifier is nothing but it's a IC741. It's an integrated circuit. It's an 8-pin chip available in the market. If you look at this, the name itself it is showing it's a non-inverting amplifier. So let us consider this is an amplifier and you are going to give some input. Say your input voltage, let it be it's a 5 volts. I'm considering the gain of this amplifier is 2. Then definitely you will get 10 volts as an output voltage. Because it is a non-inverting amplifier, so whatever the input you are given, you will get the amplified output with respect to the input and gain value. In this case, it consists of two resistors R1 and R2. Here R2 sometimes it is referred as a feedback resistance RF. So how to design? So this is the gain formula. The gain formula of non-inverting amplifier is given by 1 plus R2 divided by R1. Let us consider my input voltage is 1 volts and I'm taking the resistance R1 is 1000 ohms and my feedback resistance R2 is 10,000 ohms. Then what will be the output voltage? It's very simple. The gain is given by V0 divided by Vin, which is equal to 1 plus R2 divided by R1. So now you can easily calculate what is V0. V0 is equal to 1 plus R2 is 10,000 ohms divided by R1 is 1000 ohms multiplied with Vin is 1 volts. So you will get V0 is 11 multiplied with 1. So at last you will get V0 as 11 volts. So your input voltage is 1 volts and output voltage is 11 volts and your gain value is, in this case, gain value is 11. This is the way the non-inverting amplifier is working. Now I am going to simulate the same with the help of Matlab. I am straight away moving on to the Matlab. So where to pick the elements first? So if we want to develop a non-inverting amplifier, I need an operational amplifier, 2 resistors, input voltage source, voltage measurements for input voltage as well as output voltage. I want some scopes. Okay, these are the components which I need. So where to pick the elements? Go to library browser, go to Simscape, go to foundation library, go to electrical. There you are having electrical elements, electrical sensors and electrical sources. So from that you can easily pick the elements. Go to electrical elements. I need op amp. So if you look at this, here I am having operational amplifier. Take this op amp. And then I need 2 resistors. I need a voltage sensor. Similarly, I need a source, AC voltage source. You can use both AC voltage source as well as DC voltage source. Okay. Let me connect it. Let me fix this resistor as R1 and value of resistor, let it be it's a 1000 ohms. or you can say it's 1 e power 3. So it's a input resistor, and let me take this is R2. R2 is a feedback resistor. Little bit, it's a 10 e power 3. So now I'm going to connect it accordingly. The voltage source, I want to measure the voltage source. Let me take one voltage sensor that should be connected in parallel. So this voltage source is given as an input to the operating amplifier. If you look at this, this is op amp having both a positive as well as negative terminal. If it is a non-inverting amplifier, you have to feed this input to the positive terminal. Suppose if it is an inverting amplifier, you can use negative. Okay. Now this R3 is connected as a feedback. R2 is connected in the feedback system. And R1 is connected here like this. And that should be connected with the negative because I need electrical reference. So negative of voltage source, negative of sensor, and this resistance negative will be connected with the electrical reference. Now I'm going to measure the output voltage. Like this. Now I want to see both the outputs. Let me take a scope. Here scope belongs to Simulink, whereas these blue color elements belongs to Simscape electrical. It's a physical systems. So you cannot straight away connect the voltage sensor with the scope. We need a PS to Simulink converter. Go to view, go to configuration parameters. Make its number of input ports as 2. And take 2 converters, PS to Simulink converter. And I need a solver configuration. Without solver configuration, it won't work. You have to connect it anywhere in the system. Okay. I'll change the background. Channel 1, make it as 2. And my input voltage, let it be in black color. And go to channel 2. I want output voltage to be in red in color. Fine. So now you can feed the inputs. First of all, go to AC voltage source. As per our design, I'm giving the values. So whatever the peak amplitude I'm using, let it be, it's 1 volts. So definitely it will give you the output voltage of 11 volts because as per the value, as per the design, the gain is 11. The frequency of inverting amplifier, let it be, it's a 1000 amps, 1000 hertz, sorry, 1000 hertz. And then voltage sensor does not require any inputs. Similarly, go to operational amplifier. It does not require any input. Let it be same as it is. Go to R1 first. Make sure that the R1 resistance is 1000 ohms. You can type 1000 or 1 e power 3. Both are acceptable. Go to R2. This value is 10,000 ohms. And go to stop time. I'm making sure that it is a 0.002. Now if you run the system, you will get the output. If you look at this, it's a non-inverting amplifier, right? This one is your input voltage. It's a 1 volts. And this one is your output voltage. It's coming around 11 volts because my gain is 11. So this is the way the non-inverting amplifier is going to be work. Suppose if you want a smooth output, if you look at this, the sinusoidal signal, it seems that it's not a smooth sinusoidal. Okay, go to modeling, to model settings. Go to solver details, go to max step size, make sure that it is 2 e power minus 5. Now again, go to simulation. If you execute the file, you can see that you will get a smoother curve because you are increasing the number of samples to study. So this is nothing but it is a non-inverting amplifier. Okay, so this is the way you can simulate. I hope this video will greatly helpful to understand how the non-inverting amplifier is working with operational amplifiers. Thank you. Kindly subscribe to the channel. If you have any queries, drop a mail to this mail ID.